further, so I would like to know what is the background of the audience for today. So as you can see in the screen, so this is the QR code that gonna be directed you to the what we can call as a Mentimeter. So you can scan this QR code and then you may answer the simple questions, which is I want to know what is the demographic of the audience today. So, or in other words, I want to know you. I want to know you more. So, or in pepatah we said that tak kenal maka tak cinta kan. So I want to know you more. So and then there will be a lot of the session, voting session like this throughout our lecture. So trying to get you into the lecture session. Okay, so if you have any difficulties to access the QR code, so I will give you the link so that you can directly click and go to the Mentimeter. So I will give in the chat box. So if there are any problems, just let me know. So because again, I want to know what is the demographic of our audience today. So and then I want to get to know you more. So perhaps that we can have some sort of the interaction session. So that can give more benefit to us for today.
Dr. Azmal?
Yes.
I try to scan the QR code.
Yeah.
And then, but it's stuck in this second page. I got notified, please wait for the presenter to show the next one. Is it correct?
Okay. Yes. Because you have to see what the outcome of the first slide first. Okay. So.
Okay.
Okay, so I want to see how old are you guys in this particular Zoom room. So perhaps that. Okay, so at the moment, majority are 20 years old. So teenagers. Okay, so there are 6 participants 22 and above. So but are all of you are in bachelor programs or in diploma programs? Anyone can answer? So as I mentioned earlier, we can have interactive session. So don't be scared to answer the questions. So we can have the presenter and audience relationship here. Okay. Anyone to answer? Majority, are you in bachelor or degree program, or are you from diploma program?
In here, we call it as Diploma 4. Diploma 4 is equal with a bachelor.
Bachelor, okay, right.
Yes, bachelor.
Oh, is it S2, is it? S2?
No, S1.
S1, okay, right. Okay, at the moment we have 42 respond. So we are here about 80 plus or 100 plus at the moment, participant. So maybe we can get more feedback. Okay. So because the thing that we're gonna discuss or the thing that we're gonna see today is more toward what we can bring to the future of our architecture. So, but in your case is what you can bring forward for the future architecture of Indonesia. So this is the thing that we have discussed in Malaysia. So for example, how we're gonna bring our heritage forward. But most of the researchers, for example, most of the architects or most of the lecturers or most of the researchers that discuss about this topic is not entirely from teenagers researcher or young researcher. So most of them are a bit senior researcher or maybe old citizen. Okay. So maybe when we do the discussion here, so maybe we can open up the window of opportunity to bring forward this particular topic and issues forward. Okay, so at the moment, so why I put 17 years old, because at the moment, last year we have one student from Indonesia enrolled in our program in UTHM. So her age is 17 years old. So that's why I put that 17 years old. But in Malaysia, for example, for 17 years old, so we are still in school. But last year we have a student, one student from Indonesia, and then her age is about 17 years old when she enrolled into our program. So that's why I thought that maybe the demography here for the age today, maybe the majority coming from 18 or 19, but surprisingly, so they are 20 and 21 years old that become the majority here today. Okay, so I guess that's for this voting session. So we can conclude that the 20 and 21 years old is the majority of participants or audience here today. Okay, so let's move to the next. So can you start to voting for the following slide? If you have any difficulties, just let me know. Cannot. Okay, hold on.
To the next slide. I can't.
Hold on. Hold on. So still cannot for the second slide.
Cannot. Still cannot. For me, cannot. They asked me to refresh, but still stuck in the first slide.
Okay, hold on. Supposedly it will be a ball. So can anyone try back? Yo, oke tuh.
Yuk.
Cari muka biasa orang-orang. Okay, anyone?
Cannot.
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 Okay. I don't know what happened here. Okay, but okay, never mind. Maybe we can skip for this vote. Okay, so for the second slide, actually, I'm asking. So all of the participants here today, are you coming from architecture background, or maybe are you coming from any related built environment program? So because as you can see that from the website, they are supposed to be the program, the civil and architecture program. Plus the management something program that related to environment, built environment. So I hope that most of the participants here today is coming from architecture background. So maybe because our discussion will be much more related to the architectural and civil, perhaps in a way to what I'm going to share is about how we're gonna do the survey for the existing buildings by generating the point cloud. Okay, so this is the outline for today. Sorry for that technical glimpse just now because I don't know what's the problem for that voting. Okay, there will be 4 sections for this session. So the first one, so I will give the brief introduction on what is that architectural heritage documentation. So I will give the overview, what is the importance of architectural heritage documentation, what is the issues and challenge, and then followed by second section, which is architectural measure drawing. So what is the importance? How we conducted the measure drawing on site, and what is the issues and the challenge for the architectural measure drawing. So and then the third one is I will give the overview and background on the how we can generate the digital point cloud documentation by using the photogrammetry and by using the LiDAR. So I will give the brief introduction, what is the point cloud, and then what we can do with the point cloud. And then the last section will be the building survey. So I will show some sort of example what we have done by using this method or by using this technique in surveying or in documenting a few of the buildings that we have done by UTHM students. So maybe in future we can do some sort of collaboration, perhaps in between UTHM and Andip in future. Okay, right. So again, so I hope that this is another voting. So why? Because I want to know again, as I mentioned earlier, I want to know the demography and I want to know what you have done. So in this beginning part of my lecture, this will be a lot of the voting session. So because again, I want to get the interaction, I want to get the feedback from you guys. I want to know you more. So maybe you can try to answer these short questions. So I hope that there will be no technical error this time. So if you have any problem, so you can let me know. So I put in the chat the link if you have difficulties to scan. Okay, I will put the live result. So the question is, have you learned any history or any theory architecture subject in your program or throughout your program? So at the moment we have 12 response. So it's balanced. 6 say yes, 6 say no. So we are looking to get more feedbacks from you guys. So, but Dr. Rati, is it in the program have any history or theory subject? In the,
Yes, we
yeah.
have. Yes, we have. For the architecture concentration, this subject is in semester 5 or year 3. Year 3.
Okay. So I hope that we can get majority say yes. So because again we're gonna, the thing is so as I mentioned earlier, so when we do the research on heritage area of architecture, so
fuck you, bitch.
Yes, most of the not really keen to study on those particular.
Oh, daddy, fuck me in the asshole.
Yes, Sabrina, you want to talk something?
Very untasteful.
Yes, Dora.
I don't think that I really appreciate what is happening right now. Like, I just joined and I heard someone.
Dora, fucking kill yourself now.
Are you actually?
For the response, so perhaps we can get more response.
My response is that you should put your fingers up your own ass and come on them.
Sorry.
That's very untasteful. I'm not even gonna lie. I'm sorry, but like, I don't.
Fuck you, fuck you, fuck you, fuck you, fuck you, fuck you, fuck you. So Dora Harris is requesting control of my screen. So yes, Dora Harris, do you have any questions or feedback? Is this our students over there? Okay, we're still waiting for the feedback. So perhaps that we can get more.
My feedback is that you need to bend over and get on all fours now.
Sorry, I think it's not from our.
Sorry, it's not from our participant, doctor. We don't know because I checked all the participants are muted. Only you and me don't know.
Dora Harris, is it in the list also?
No, no name of Nora Hadis in here.
Who? But where is it coming from? So I don't know what happened. Maybe there are some hackers outside there. Okay.
Bring back Jim Crow laws.
Oh my God.
Yes.
Oh, committee.
Okay, never mind. So maybe there are some technical issues that we can control. So so at the moment, from 23rd response, so we have around 15 coming. 15.
Killblock nugget.
Who is that actually?
Don't know, doctor, but I think from the dialect, it's not from Indonesia.
Yes, because it's not appropriate.
Yeah.
Okay, so we just proceed with our content lah. Okay, so 15 of you are said that yes, you have joined, you have learned the architecture history and theory. So and then while another 8 still.
I've learned the history of Jim Crow laws, and I think they should be reinstated.
Yes, Dora, do you have any problem, Dora? I don't know where he's coming from. So maybe Okay, so we just continue to the next voting. So previously, I'm asking that have you learned any architecture subject or not in the throughout your studies? So at the moment, I'm asking another question, which is what you have learned throughout the thing that you have learned in the subject architecture history theory in architecture. For example, you can state it in the simple words. So maybe you type that heritage, for example. So if you have any difficulties, again, just let me know. Oh, sorry. I have a request to remote control my screen now. I don't know what happened. So I just decline that. So, but committee, if you have any request to remote control my screen, you can let me know. So I don't know what happened. There are some alien in our session today. Okay, so if you have any difficulties or if you have any problems to access the Mentimeter, so maybe you can let me know. So again, this is I just want to see what your feedback and what you have learned. If you said that you have learned a history subject, what is the content that really keep in your mind? So for example, about what is the history? Yes, preservation, conservation. So this is a part of the historical subject that we have learned. So again, as I mentioned earlier, so during when we talk about the history, so when we do the research, for example, so we don't have much interest from the young researcher, for example. So this maybe become because of the nature of the history itself, that the way that we learn history, the way that we conduct the research history is, we can say that maybe is old school. But at the moment, we have a lot of the tools, we have a lot of the technologies, even though that we do the research in history. So the way that we do the research is by using the current technology, for example. So that is what happened now in the historical studies. So maybe before we just simply read the books and then we just go to the site, taking the pictures. But at the moment, the orientation is already different. The methods already developed. So perhaps that we can get more young researcher or young students that put their interest in history subject. But at the moment, we just have to respond. So as I mentioned earlier, perhaps that we can get more response. So, but never mind, we just proceed to the next content of the session. Okay. So we start by what is that architectural heritage documentation. So again, to reflect back the answer just now. So it's merely what we can call as a part of the conservation of architectural heritage. So the role of historical documentation is widely known as the main medium in conserving and recording the intrinsic and extrinsic values of built heritage. So as mentioned earlier, so for example, in Indonesia, for example, you have that numerous numbers of heritage buildings, notable heritage buildings. So this is what we can see now. But in future, we don't know that either the building gonna be sustained or still intact in the site. So that's our role as architectural field, that we can do the documentation, we can record, we can conserve that throughout the documentation. Okay. So heritage resources with both material and non-material types are considered as the living memory of individuals and nation. So for the importance of this resource, so national and local efforts have been made and continue to be made in order to conserve them. So documenting the resource of cultural heritage in all its forms and types is considered as one of the most important and first operation to conserve these resources. Okay, so that's mean, so documenting. So this is the first step that we can do. So we know that in a way to conserve the heritage building, we can do the we can do the maintenance, for example, and then we can do the repairing works, for example, but it comes with a cost. So, but the first step that we can do is documenting them. So why? Because with that documentation, so maybe in the next 100 years, so some of the our future generation, they can still see, they can still valuing what have been done in our architecture in the past. Okay, so in total, architectural heritage documentation refer to the sets data documentation of the on-site record of a physical heritage built environment characteristic and the record of historical background and development. So the thing that we record is the on-site condition of what happened to that building inside, on-site, and then plus we're gonna record what have been happened to that particular buildings. Are they undergone the renovation process and so on? Are they have gone the renovation works or repairing works? So that's the thing that we have to record. So because why? Because by recording this, we can trace the original characteristic of that particular buildings or that particular component of built environment. So it can be recorded in the form of the sets of the drawings or narratives or media representation like video or documentary and any other sources of documentation. And our heritage building. So, but it's because of the issues. This is what happened in Malaysia, for example. So we have two major issues here, which is the first one is the transformation of original characteristic of heritage built form. So that means the original heritage building or heritage built form, so they have undergone the transformation. So just like our house, so we will do the renovation to expand the spaces, for example, from living room to another rooms. So when the transformation had been done, so maybe in future we cannot try to record what is the original states, what is the original intention of the designer for the buildings in the past. So this is the thing that we have to critically see lah. And then number two is the vanishing of heritage building. So apart from the transformation, so which is could be done by the owner. So on top of that, they are vanishing heritage building. So we can say that we can say that some of the buildings slowly abandoned and then slowly collapse to the ground. Okay. So for example, so we're gonna see. Okay, so this is the first. Okay, as you can see here, this is the origin. Maybe this is the origin characteristic of the Malay traditional architecture or Malay traditional house. You can see here the sophisticated form and language of what Malay traditional architecture are. And then you can see, for example, here the what we can call as a jendela labuh, the full height opening. And then you can see that this is the elaborated modules from the rumah ibu to rumah dapur. And then you can see the crafts, the ornamentation. So this is somehow highly reflect to what Nusantara or Tanah Melayu glorious day of architecture, of what our centers have done in the past. So you can see it's already captured our eyes. This is what we have done, what the glorious days of our architecture in the past. So when the transformation had been done, so this is what happened. Okay, so as you can see here in the screen, so as previously I showed to you the jendela labuh, the full height window. So it's already been replaced by the sliding window, and then plus here, as you can see at the right side of the picture, so from the old Malay traditional house, so they renovate that into Hello Kitty house. And as you can see here, it's look like the pediment here, and then plus the ionic column here that's coming from Rome. So this is a bit juxtaposition, or there's a bit we can call that as a in Malay word we can call that rojak, for example, right? So the mix of language and the mix of language. So this is the thing that that really happened in Malaysia, for example. So if this keep happening, So in future, what we can show to our future generation? So is this the architecture that we're gonna show to our future generation? Is this what we have done in the past? So definitely no, right? So because of that, we have to record, we have to document what have been done, the original characteristic of the architecture that have been done by our ancestors from past. Okay, and then this is another issues, which is some of the buildings, some of the houses are left abandoned and unmaintained. So because this is from our research before that we went to the Kampung Laut at Kelantan. So we are studying about the Malay house in the Kampung Laut. So if you know that the Kampung Laut, they have the mosque, the notable heritage mosque, which is the Kampung Laut Mosque. So this house is located in that particular region. So as you can see here, the house is left abandoned, unmaintained. So because of a lot of the reason, some of the reason is as we know that the craftsman, or we can call that the tukang. So if you want to get their service, because their number is limited, so the cost for hiring them is a bit expensive. Plus the material itself, for example, timber. The timber itself is quite expensive. So at the end of the day, so the owner is unable to maintain their house. So they just left it abandoned, collapsed to the ground in future. So but this house is still intact on the site, but we don't know in future what happened to this particular house. Okay, and then this is an example, the house that collapsed. Even though this is the small size of Malay traditional house, but it's still heritage building. So as you can see in the right side, so it's already been damaged, collapsed. Maybe in the next years, it's already collapsed to the ground. So before this happened, so it is crucial for us to conserve them. It is crucial for us to document them. So as I mentioned earlier, if we want to conserve them, so maybe it will become with the cost. For example, if we're gonna do the repairing works, if we're gonna do the maybe adaptive reuse, I don't know. So but it will become with the cost. So but if we just merely documenting it, or if we just merely survey it and record that in the proper set of the drawings, so maybe even though the house itself collapsed, so we still have the data. We still have the archive to show to our future generation in future. Okay, so the problem is, as you can see here, this is one of the mudah.my. So this is the platform that if you want to sell your items, if you want to sell the things, pre-loved item, for example, you can go to this website, you can sell that. As you can see here, so the components of the heritage building, they disassemble them and then they just sell them online. So for example here, as you can see here, tangga kayu rumah Melayu traditional, the staircase of the Malay traditional house. They say that they sell that for 180 ringgit. So yes, of course, when there is supply, there will be the demand. So when there is demand, there will be the supply. So that's mean because people looking forward to buy that component of the house. So if these activities keep happening, so maybe in future, all of those components from Malay traditional house, from our heritage building, going to be sold. So there will be not any physical heritage buildings that we can see anymore in future. I don't know. So before this happen, so this is our role. So what we can do is we document them before the house itself, before the building itself, gonna be disassembled pieces by pieces. Okay, so this is another thing. So this is, I don't know, I get this post in the Facebook recently. So which is the owner itself intend to sell the house just for only 2,000 ringgit, the whole house. Why? Because they claim that the house is haunted because it's located near to the graveyards, and then they said that there are some ghosts inside the house. So that's why they want to sell that in the low price. So, but I don't know whether this is correct or wrong, or is it just been made for fun with people. But this is the post that I seen recently in the Facebook. Okay, so when these particular activities keep happening from time to time, so yes, definitely in future we will not see our heritage building intact on the site. So because they've been sold, they've been sold, and then they've been keep assembled components by components. As you know that the timber in our heritage building, so it's really valuable. So because they use the original timber. Okay, sorry. Sorry because today is a public holiday in Malaysia, so my kids here in my room. Okay, all right. So okay, there's some voting more, but I guess I just skip that because I don't want any problems or error. Okay, so we go to the second part, which is the architectural measured drawings. Okay, so architectural measured drawing refer to the systematic procedure in documenting and understanding the characteristic of built environment, specifically on site constructed buildings. So the outcome of the documentation generally represented by visual communication, illustration, and literature as part of the educational tools in understanding the building's context, significance, cultural values. So architecture Okay, so the procedure itself involves multiple series of qualitative and quantitative data collection. So it includes the physical building components measurement, supported by the oral and literature documentation that represent the narrative historical background of the buildings. So when we do the measured drawing, we go to the site and then we're gonna measure the buildings component by component, part by parts, in a way to obtain the exact measurement of the buildings. And then on top of that, we're gonna do the literature documentation. So most of the time, we're gonna interview the owner of the house or maybe the respondent that living surrounding that buildings or surrounding the house. So the measurement itself plays an essential role in determining the actual record and the condition of the buildings before it's been translated into comprehensive set of architectural drawing in the form of 2D and 3D drawings. So, but before we go further, so is there any exercise or any assignment or maybe any subject in NDIP that do on measured drawing? Anyone to answer?
Yes.
Is there any subject or any courses or any exercise for students to do the architecture measured drawing?
Yes, we have. We call it as in Indonesia. The name of the subject is Teknik Survey.
Pardon?
So in Indonesia, the name of the subject is Teknik Survey. Teknik Survey.
Okay, all right. So, but they are okay. So
Yeah.
that's good.
Yes, so the student, the lecturer will ask the student or give the assignment to the student or give the task to measure some of the buildings, and then they will redraw the building according to the
Condition.
yes, correct.
Okay, right. So I believe that most of you already undergone the exercise. Okay. So so the most critical part of the architecture measured drawing is to determine the exact measurement of the buildings. So again, as I mentioned earlier, so measured drawing itself is considered as a predominant component in architectural heritage documentation. So, but on top of the measured drawing, so in Malaysia itself, in our country, so we have the department, we call that as a Department of National Heritage, which is they do the effort to conserve the buildings by gazetting the buildings following the UNESCO SOP and so on. So as you know that when the heritage buildings are being gazetted, so it will become with the specific guideline and restriction. So for example, if your house, for example, been gazetted by National Heritage Department, so you are simply cannot do the renovation, even though that the cost of the maintenance is funded by this department, but there are a lot of the restriction. So most of the time, there are some cases that the owner of the buildings are reluctant to gazette their buildings. So because of this particular restriction. And then on top of that, even though that there are some effort been made by this department, so the visibility of the project, so still the people don't know how they're going to conserve their house, how they're going to gazette their building or houses. So it's a bit dilemma over there. So even though that efforts have been made, so as I showed to you earlier, the example, so a lot of the buildings still remain abandoned at the site. So maybe in future that the notable heritage building itself is gonna be gone or gonna be vanished in future. So this is the thing that we can contribute, which is we do the architecture measure drawing. So even though that the house itself collapse in future, so we still have the record, we still have the document. So yes, contrary to the avoided gazette procedure that regulatory immerse, so most of the owners willingly allow their buildings to undergo the measure drawing procedure. So most of the time when we do the measure drawing exercise, so most of the time that the owner will willingly openly to allow us to do the measuring for their house. Okay, and then due to its significant importance, this measure drawing, so the procedure itself should be evolved with the current technology and methodology. So this is I mentioned earlier. So previously when we said about the historical study or historical research, so we have paradigm think that okay, so when we do the architectural research history, so the method itself is orthodox, so the old school methods. But no. So at the moment, there are lots of the methodology, there are a lot of the tools that been implemented or that been adapted in the architectural historical research. So there's the thing that we will develop more and more in future. Okay, so I guess I don't have to say that because I believe that most of you already undergone the exercise, the measure drawing. So, but commonly, we will do the measurement by using the measuring tape, or maybe we're gonna use the laser distance meter. So and then most of the time, so for example for the roof part, so for student project, for example, so of course we're gonna use the thing that we have. Okay, maybe for the commercial project, for example, for the documentation, in a way for them to measure the roof, for example. So maybe they can use that scaffolding, for example, to climb over the roof. But for the student project, it's a bit limited. So most of the time, I still remember that during my studies before. So when we're gonna measure the roof, so we just use the scale and proportion method. So we let our friends to stand beside the house, and then we just taking a picture, and then we're gonna scale that the size of the roof in the AutoCAD or in the 3D software. So because of that, the accuracy and then the exact dimension of the roof, for example, still being debatable, even though that we use the laser distance meters or we use that measuring tape. But there are some part of the buildings that unreachable, we cannot reach that. So because of that, we use that scale and proportion techniques, for example. Okay, so this is in total the summary, which is architectural historical documentation. The main medium is by using the measured drawings. Okay, and then we have the issues. We can call that as a gazetting dilemma, which is even though the Department of National Heritage did some effort, so it's still in dilemma. So some of the owners don't know about the effort, and some of the owners are reluctant to the effort. Okay, and then the only thing that, as I mentioned earlier, again and again, so we can do that measured drawing. So, but of course, at the moment, so if we still by using the traditional method, the orthodox method, okay, so there are some challenges. So this is the issue, the limitation. So first one is the whole procedure of measured drawing itself is a bit time consuming. So if I still remember that during my time before, so in a way to measure one medium scale house, Malay traditional house, it took us about 1 week to complete that exercise, 1 week. And then for the bigger scale building, so maybe the time could be more, maybe 1 week, 2 week, or 1 month, I don't know. So, and then apart from that, again, the accuracy of the measurement is still debatable. So with some of the non-measurable measurable part or components, as I mentioned earlier, we just use the scale and proportion technique. Okay, so because of that techniques, so the accuracy will be debatable. Okay, and then this is the issues that I mentioned earlier. So if you come with the commercial project, for example, you will have the proper equipment, but what happens if you don't have the proper equipment to climb over to the roof? So this could be the scenario. So hazardous, and then plus the accuracy. Okay, so because of that, so as I mentioned earlier, so we come to the new paradigm of what we can do with the historical documentation or heritage documentation of the buildings. So the technique that we propose, and then this is the technique that we've been used in UTHM for these past 2 years, for example. So we call that as a digital point cloud documentation by using LiDAR. Okay. So point cloud, what is that point cloud? Space. So point cloud collecting a large number of single spatial measurement into a data set that can represent as a whole, and that is commonly generated by using LiDAR, photogrammetry, and other specific computer software and program. Okay, so as you can see here, so this is the point cloud. So what you can see here, what is the surface represent? So anyone to respond?
Is it contour? Soil?
This is, yes, this is a contour, but as in total, actually, you can see that this is the face of the human, actually. So it's developed by the series of the point that we can call as a point cloud. Okay, so this is much more. Okay, so this is the axis I mentioned earlier. So as you can see here, this is the nose, this is the mouth, this is the eyes, right? So this is perhaps scanned by specific tools in a way to represent that into the set of data that we can call as a point cloud. So by seeing the point cloud, we can see that, oh, even though that coming from the points, we can see that the surface itself is representing the form or the shape of the human face. Okay. So, and then for the photogrammetry, so photogrammetry referring to the techniques of measuring by using photographs, which is the photogrammetric process is intended to derive accurate information from aerial photographs and generate the photographic image from which all errors can be removed. So, or in simplest word, so we're gonna use the photogrammetry for the part or for the components of the buildings that unreachable, that we cannot reach. So most of the time is roof lah, the roof, the component of the buildings. So with the integration of standard measurement techniques and photogrammetry, so the collected measurement data ascertains higher accuracy, yes, because when we're using the specific tools, so in photogrammetry, for example, the point cloud is developed from the photograph. So but the photograph itself have to be taken by using the GPS coordinated device. For example, phone. For example, you have the camera, right? And then most of the time, phone come up with the GPS capacity. So, but for our case, so we are using drone to get the photograph from the roof profile, and then the drone itself have to be occupied with the GPS capability. But most of the drones actually they have the GPS capability, right? Because if you are flying the drone, for example, so for example, if your drone are lost from your site, so you can always to press the home button, which is the drone will flying back to the origin coordinates that when they are flying at the beginning. Okay, so in the survey practice, the photogrammetry is executed by using the aerial photograph by GPS connected drone, as I mentioned earlier. So yes, the reason why we are doing the photogrammetry is for us to obtain the set data of the point cloud. Okay, so this is the proposed workflow that we use in the UTHM. So for example, this is the buildings on site, and then we're gonna use the drone to take the aerial photographs of the buildings, and then we're gonna use the LiDAR scanner in a way to get the data, the point cloud for the site elevation of the buildings. Okay. Hold on. So committee, is it because I'm trying to do the annotate from my device, but I cannot do that. Maybe committee can change the setting. Anyone, the host maybe? So maybe I can annotate because I want to show some of the part.
Committee. Can you
The host, maybe you can change the setting to allow for the annotate.
I'm sorry, but could you repeat it again?
Can you change the setting to allow the annotation in this particular Zoom meeting? So because I cannot see the option here in my Zoom interface. Can you help us to change that?
Okay, Mr. Please wait a minute.
Okay, all right. Okay, now while we are waiting the settings, so we move over. So again, just to recap back, so this is the workflow that we propose, which is we're gonna use the drone to get the pictures or photograph of the aerial of the top part of the buildings, and then we're gonna use the LiDAR. Because the LiDAR itself is this is the on-ground tools, so it cannot be fly. Okay, so that's why even though that we use the super expensive tools, so there are still some limitations. So as a result, so we're trying to work with the tools that we had in UTHM. So at the moment, for example, in UTHM, we are in the built environment, Faculty of Civil and Built Environment faculty. So we have the surveyor in our faculty, we have the geometric expert in our faculty, and then we have the architecture in background. So in surveying, so the drone have been used widely in a way to mapping the condition of the site. So sometimes they are mapping the ground for the vegetation purposes that they do the collaboration with the Department of Agriculture, for example, and then they're mapping the river, for example, for the record of their research. So the drone have been used widely in their program, in their research. So because of that because of that technique, so we are trying. We ask them to assisting us. So how we're gonna do that in a way to map the buildings. So at the moment, yes, we have been trained by them, and then yes, we are able to map the top part of the building by using such technique, which is the photogrammetry by using the drone. Okay, is it okay? That setting. Can you change that? Okay. So maybe while waiting, we move to the application. Okay, so on the previous part, I talked a lot about the theory, right? So I talked in the sense of the history, so in the view of the importance of our effort. Okay, so right now I will show that a few of the example and what we have used and what we have been done. So that's why if possible that I want to get the annotation, so maybe I will explain in details what we have done by annotated in the screen, but maybe we're still waiting now for that setting. Okay, so this is the tools that we call as LiDAR. This is a product by Leica. So as I mentioned earlier, so we just use this LiDAR scanner on ground, which is we just gonna scan the facade of the buildings or maybe the interior of the rooms. And then the LiDAR scanner itself have a limitation, which is for this type, we use the BLK360. So it just can scan the surface of the area within 60-meter radius. So that means if your buildings, for example, have 100 meter length, for example, so you have to set up the several points. So this is on field. This is just example. So we just taking a few points in our campus. So as you can see here, so this is the station point. We call it as a station point. So the point that we're gonna put the LiDAR. So and then it's gonna scanning in 360. So and then as I mentioned earlier, the limitation is 60 meter. So just to be cautious, so we just put that in between 20 to 30 meter in between station. So when we have a lot of the station, when we're scanning a lot of that, so this is another example. This is where we're collecting the data by using the portable device. So this is example which is when the scanner is scanning in 360 degree, so it will be provided us with the panoramic photograph. Okay, so this is the raw data that we're collecting from the LiDAR scanner. So which is as you can see here. So this is the points. This is the series of the points that scanned by the LiDAR scanner. So this is the thing that we call as a point cloud raw data. So this is the data that we not even stitch it yet. So as I mentioned earlier, so in a way to scan the whole buildings, so you're gonna set up a few station point. So at the end of the day, so after you collect the data from the site, after you scan the building on site, so you have to stitch the station point. You have to connect them together. Okay. So in a way to produce the whole buildings. So for example, this is the completed the process data. So this is the red dot here. This is the station point. Okay, and then we have to connect them. We have to stitch them together in a way to give the outcome of the point cloud for the overall buildings. Okay, and then this is the photogrammetry that I mentioned earlier. So we use drone. So for example, we use for this project, we use 2 sets of drones. So we use the DJI Phantom Pro and we use the basic drone just for taking photographs. And then this is when our student flying the drones. So I will explain later for the details. So we start by the photogrammetry. So as mentioned earlier, so we use 2 techniques, which is the first one is photogrammetry, second one is LiDAR. So we're gonna start by photogrammetry. So okay. So as you can see here, so as you know that when we are flying the drone, so we can fly that freely, or we can have that what we can call as a pre-flight plan flying. So which is, for example, as I mentioned earlier, in a way to get the exact measurement or exact data from the top part of our building, so we have to plan our flight. So as you can see here, we use the software we call that Pix4D-Art. We set the route plan of the drone. So as you can see here, we use the Phantom 4 Pro. So we set that in the grid manners. So why? So I will show to you afterwards why we are setting in that particular manners. So because we want to get the photo as much as possible. But again, even though that we are using the drone, there are some limitation. For example, for this DJI Phantom 4 Pro, So the battery itself is limited to 30 minutes to 40 minutes per fly. So that's mean we have to be aware of that capacity. So somehow, because we don't want to have any technical problem, for example, during the fly, so the battery is drained, for example, during the fly. So we want to avoid that. So we're gonna do the plan critically how we're gonna fly our drone. So usually we just use that in the grid manner, and we just use that in the oval manner to get the 360 fly around the buildings. So this is the map, because of the drone itself is occupied with the GPS capability. So you can set it up, the plan, in the maps that embedded in the software. So this is the, as you can see here, this is the series of the photograph. So when you start the plan flight for the drone, and then you can set up where's the point that the drone gonna take the photos. So for example here, this is the series of the photograph taken by the drones. So this is the image, the drone flying on that exercise. Okay, so this is the result. So when we finish flying the drone, so we get a photograph, and then this is the point. This is the point that where the photos have been taken. So can you see the red dots here in the photos? Okay. So and then this is we use the software, we call that as a Agisoft MetaShed Professional. So by using this software, so it's gonna generate the point cloud from the photograph. So as you can see here, this is the detail of the series of the photograph. As you can see here, this is the altitude. This is the height where the drone gonna fly above the ground. So we set it up 30 meters above the ground. So because for this building, the height is about 10 meters, 10 to 15 meters if I'm not mistaken. So we set the drone to fly above the highest part of the buildings. So we set it up about 27 meters above the ground. And then this is the longitude and latitude. This is the GPS coordinate. So when we import the photograph from the drone into this particular software, so it's automatically will provide the maps. As you can see here, this is the on-site maps. And then by using the data longitude and latitude, so we can get the exact location of the buildings. Okay, so this is the point where the photos have been taken by using the drone. Okay, this is from the side. So as you can see here, actually the height from this point to the ground is 27 meters. Is it okay? Is it the setting okay, committee, that allow for annotation? So because I cannot see that option yet. Is it possible, committee?
Committee, can you guys help Dr. Azmal?
sorry for disturbance.
It's okay, no problem, doctor.
So because I cannot see yet the how to say, the annotation option over here. So for me to annotate, so because if I'm able to annotate, so I can sketch or draw on the screen that to show the details. So at the moment, so as I mentioned earlier, so from this point to the ground, so we set it up 27 meters above the ground, so which is highest than the top part of the buildings. Okay, so this is the photos. Okay, so this is the ground. So this is the outline of the buildings or site that we've taken by the drone. So for this project, I believe that we use about 100 to 200 photographers. So because this is we are scanning, we are documenting the school at Batu Pahat, because they will undergo the renovation. So before they undergo the renovation, so we document that first. So document for our record, and then on top of that, they're gonna use that for the as-built drawing for their project later on. Okay, so this is the location of the photo being taken. Okay, and then this is the raw data of the point cloud, and then this is after we process it to the dense point cloud generation. So as you can see here, the roof profile of the buildings is really visible. So this is our intention to get the profile, the roof profile of the buildings. Okay, so this is the view from the top. So this is all of the photograph that we taken from the drone, and then the building itself is located at the below the flying plan of the drone. Okay, so this is the point cloud raw, and then this is the point cloud that after we process into the dense point cloud. So as you can see here from the top, all of this particular component is visible. This is the car park, this is the hall, and then this is the class block for the school. And then even the condition of the trees itself is being recorded properly by using this particular techniques. So again, same to the point cloud itself. So the more the photo that we took in the site, and then the more accurate the data that we get. So this is from different orientation. So even the words kosongkan for the parking area in front of the hall also been taken by this by the drone, and then being point cloud. So as you can see here, we just take the profile from the roof, but we not taking any profile from the facade of the buildings. So why? Because actually we can do that if we apply the drone lower in the same level of the facade, but we avoid that because for this exercise we do that in the school. So we scared that if there are any students that gonna disturb the drone flying. And then on top of that, we are trying to avoid that if the drone is flying low, so there will be the possibilities that the drone gonna hit the trees, or maybe there are some possibilities that the drone itself gonna have the disturbance, their GPS coordinate. Because, for example, if they fly indoor, for example, so there will be the possibilities that the GPS networking or GPS link is missing. So because there are some cases in our faculty, initially we have 3 set of drones, and then at the moment it just remain one. So because 2 of the drones is collapsed during the fly, and then as you know that the drone itself we fly at 30 meter, 20 meter above the ground. So when there are some problem, and then the drones collapse to the ground, and then it's really gone. So we have 3 before, and at the moment we just have 1. Okay, so because of that we are a bit cautious the way that we're gonna fly the drone. So we just make it as safe as possible. Okay, and then so this is the outcome. So this is the point that where the photo is gonna be taken by the drone. So this is in after we remove the map lah. So which is to show the clearest scenario, which is this is 30 meter, 27 meter above the ground, and then this is the buildings. Okay. And then this is after we generate the dense point cloud by using the software. So you can see clearly the roof profile. And then with this particular set of data, we can get the exact measurement. For example, from here to here, how many meters. So without doing the scale and proportion technique anymore, that as I mentioned earlier. So because the roof part is a bit critical because the number 1 is high, and then we cannot reach that. And then number 2 is what is the best equipment that can guarantee our security while measuring that part of the buildings, right? So as a result, we just using the drone. So we just fly the drone around 45 minutes, for example, 30 to 45 minutes. And then we just get the data, and then we just process by using the Edisoft Metashape Professional. But again, as I mentioned earlier, if we're gonna use this tool, so we're gonna plan critically our works. So for example, we have to see the weather forecast, for example. So because if we fly in the drone, so the rain will be our enemy lah. So because when we go to the site, and then we already travel 100 or 200 kilometers, and then suddenly rain So because of that, we have to plan our works. For example, in order to fly the drone, we're using the rain alarm, for example. So from that, we can predict. So is it going to be clear day or is it going to be the rainy day? And then by using the drone also, so we have to get the not to say advanced but intermediate pilot for the drone. So because to fly the drone itself is not easy actually. So because for example, there are some cases before our students. So because we've been trained them to fly the drone, and then as you know that for common drone they have four propeller or 4 fan, right, to make it fly. So and then it does have a specific direction for you to install the propeller. So our student before they install it in the wrong manner. So because they are come with the black and silver color, so you have to put in the right color in the right place. So our student they put in the different color. So black, silver, and silver. So if I can annotate, I will draw that, but I just explain by my words. So when it's fly, so the drone itself is not balanced, and then luckily that it just flies 1 meter above the ground, and then the drone collapse. So it's still in good condition during that time. So because of that, we have to have a intermediate level of pilot drone, so to allow us to navigate and maneuver the drone. Okay. So and then this is after we export. So because as I mentioned earlier, so for this session, I will show to you how we're gonna collecting the data and how we're gonna process the data and bring it into Revit. Okay, so for example, so from the Agisoft Metashed Professional, so the point cloud itself can be converted into various type of file. So for example, for surveyor, they use the format TIFF for them to record the image with the proper data. So, but of course, in architectural field, so we're gonna use that for 3D modeling. Okay, so for that, so from Agisoft, we're gonna export that into the Recap Pro in a way to allow us to bring it to the Revit for us to start to developing the component of the buildings. We call that as a slicing techniques. Okay. So this is the condition after we export to the Recap Pro. So as you can see here, this is the clear visible, the roof, but you cannot see that what happened in the facade, right? So this is from the different side. So this is, as I mentioned, so this is the roof profile that we successfully record by using the drone and photogrammetry. So this is the profile that we are unable to record. So because as I showed earlier, so our drone is flying above the roof. So for the components underneath the roof or covered by roof, it will be unable to record that. So this is the non-recorded profile. Okay. So this is the roof profile successfully recorded. So this is the facade profile that not being recorded by the photogrammetry. Okay. So this is the roof profile. So because of this non-recorded profile, so that's why we have to integrate the photogrammetry and LiDAR in a way to get the full set data of the point cloud of the building that we survey. Okay, so this is the outcome of the LiDAR, which is we're gonna, as I mentioned earlier, so this will be work on ground. So we use the tripod. So we're gonna set the station surrounded the buildings, and then we're gonna scan the buildings in 360 minutes. So sorry that I'm unable to show the workflow by using the software because at the moment I'm not in the office. So because the software itself is limited to the certain number of computer. So at the moment we just put that in our campus, in our lab. Okay. So because after we done scanning the buildings, so we have to, as I mentioned earlier, we have to stitch them together by using the specific Leica software. We call that as a Cyclone Registry 360. So we have that software in our lab. And then at the moment we are in the verge of renewing the license. So because the software itself is a bit is a bit expensive and we have to renew that yearly. Okay, so sorry that I'm able to show that the interface of the software. So this is the outcome lah, which is after we finishing stitching the points, and then we export that into the Recap Pro in a way to allow us to bring it to the Revit. So as you can see here, so by using the LiDAR scanner, so it's work on the ground. So definitely we cannot get the roof profile. So as you can see here, this is a bit hollow here, but for the facade, for the interior, we are able to record, successfully record. So this is the roof profile. As you can see here, it's able to be scanned. So as you can see here, so this is me and my colleague lah, while we are scanning the building. So it should be record anything, any surface in front of the scanner. So because it will be rotating in 360. So for those who are during the scanning happen to be in front of the scanner, so it will be recorded at the surface. So this is the different. Okay, so for the photogrammetry, you can see clearly the roof profile, even the roof tiles clearly. But by using the LiDAR, you are unable to see that because we put the station on ground, and then definitely the scanner itself cannot see what happened on top of that, because just similar to our eyesight, so we cannot. Okay, so this is much more closer. So you can see here even any single words on the signage here, and then this is me actually half part of me while we're scanning that, and then this is the interior part of the buildings. Okay, see, this is from another side. Okay, so this is, you can see, this is not picture, this is the point cloud. This is not photograph. So this is the point cloud that we process into much more like 3D model buildings. Okay, so this is much more closer. Again, this is me. Okay, so this is the interior part of the buildings. So as you can see here, this hall, they're gonna use this hall for the examination. So, but during the session that we are scanning the building, so there are some students doing the activities over there for short briefing. So you can see even the fan, any surface, anything that existed on the site, any surfaces, it will be recorded into the point cloud lah. And then you can see that the stack of chairs here. So this is when we move the station to front, so to on top of the stage. So this is the view. So again, this is not photograph. This is the point cloud. So maybe you see that, oh, this is just common photograph. No, this is a point cloud. So you can use this data to developing the 3D model. So this is different. So for example, if you're just taking the photo by cameras from this point, so you will get the 2D. You cannot process that as a 3D. So but with this particular point cloud, so actually we can determine, for example, the length from this component to this component. We can easily get that dimension. So that's how the tools and technology process are developed from our ancient time, right? So just imagine that for this size of the buildings, if you just gonna use the measuring tape, for example, so you're gonna walk from this part to this part, right? So that's why it's time consuming. But with the scanning, we just put the scanner there, and then we just leave it doing their works, and then we can get this set of data afterwards. So definitely for this interior, we can use the LiDAR, we're not gonna use the drone. So because it's too dangerous if you're gonna apply the drone inside this particular area. Okay. So this is another project. Similar, we start by getting the profile of the roof by using the drones from the top, but this is much more smaller lah compared to previous project. So this is the profile of the buildings. So this is the actual point clouds that generated by using this drone. So this is after we exported to the Autodesk Recad in a way to allow us to bring it to the Revit. So this is from the side. So as you can see here, so the facade is empty. So because the drone just gonna take the profile from the top. Okay, and then this is when we we use the LiDAR. So the same building. So but as you can see here, we have about 30 station, 30 setup. So because this particular building, it have a lot of the interior space, a lot of the segregation. So we have to scan the space one by one, and then we have to scan the building from the outside. So this is the interface of the cyclone registry. So where we're gonna stitch the point. So this is the station point that we scan on site, and then we're gonna process the data by process that we call as a stitch. So because of that, we able to generate the whole model of the buildings, the whole point clouds of the buildings. So as you can see here, by navigating this software, so we can see that. So for example, because the station is distant each other, for example, from here to here, maybe around 20 meters, for example. So because of that, as in overall, so there will be the 38% overlapping in between the point, because when you scan in this point and you scan in the point, so you will get the different set of point cloud data. So maybe, for example, here you can get this radius, for example, and then from this point you will get this radius. So the overlapping part, this is the thing that gonna stitch the points together. So because of that overlapping, so it's have 38% overlapping, so it's considered as good overlapping. So this is in the interior. So as you can see here, the station point in the interior. So we have stitched them together, and then as you can see here, all of these are point cloud, and then somehow is able to see as the pictures. But this is the point cloud that we're gonna use in developing our 3D models later on. So this is after we export to the recap. So this is contrary to the pictures that I showed earlier, which is you see that the clear roof profile on top of the building, but at the moment, so the roof profile is missing, but the side profile of the buildings, the facade of the building is clearly be seen here. So this is a project Batu Pahat as well, Geodet Batu Pahat. So even the gate also will be recorded while you're scanning the buildings. So again, this is, you can see here the missing part of the buildings. So because the scanner is on ground, so this is the thing that unable to read by the scanner. So that's why it's remain empty or hollow here. Okay, so this is from another view lah. So you can see here, so this is me and my colleague scanning. So they are challenged by using, because while we are using the LiDAR scanner itself, the scanner itself is a bit expensive. So at the moment we have 2 set of scanner. So we buy that scanner. For one scanner is around 120k ringgit. So I don't know how to convert that in rupiah. So 120,000 ringgit. So it's a bit sensitive tools. And then while we are scanning on the site, for example, for this exercise, we have to put our scanner in the middle of the road. So that's why we have to control the traffic to avoid the cars hit the scanner, because if the scanner is falling down to the ground, for example, or to the road, for example, so it have to be recalibrated. So at the moment, in our country, Malaysia, for example, we don't have any Leica center. We have to send them to the Singapore, and before they send it to the Sweden, for example, for recalibration. So it's a bit sensitive tools. So even though we buy the expensive, so it's a bit sensitive. So we have to be careful. Similar to the drone. So the plan is critical in a way for us to do the survey. So we have to critically plan, and then we have to come with the numbers of the colleague or researcher during the process. So in other words, we as simply cannot do that alone. So because while we are scanning, so of course we have to ask our colleagues or our fellow researcher, for example, to control the traffic, for example, to avoid any unnecessary accidents, for example, during the whole process. Okay, so this is from another view. So even the vehicles, the motorcycle here and the cars here, this will be scanned as well, as long as the vehicle is there on the side. So this is from side. So this is the thing that I mentioned earlier. So we put the scanner in the middle of the road. So this is the road actually. So there are car passing through this road. So but we have to diverge their way in a way to allow us to do the scanning, because for every station, so as you mentioned, as you see earlier, so we have about 30 stations. So during this exercise, we use 2 scanners. So one scanner, we're gonna scan about 15 stations. So one station, the duration of the scanning is around 6 minutes plus. So that means if you have 10 stations, so you're gonna have around 1 hour plus lah. So for this exercise, actually we do that around, we start by 10 o'clock in the morning and then we finish by 3 o'clock in the afternoon after we scanning the building. Of course, will be the technical issues. For example, during this exercise, during that exercise. So because of these technical errors, we have to resetting it again and again until it works. So that's the things commonly happen during on-site works, the technical issues. So this is from the interior part. So as you can see here, for this building, at the moment they use that to stop. They use that for the in Malay we call that as a tarian kebudayaan, for the tarian in English. So in this particular room, so they stop all of the clothes, uniform for them to do that dancing and so on. So as you can see here, this is the series of the clothes here. So this is how they stop their clothes for them to do the performance later on. So even the clothes, all of these shirts is being recorded as a point cloud actually. So this is after we export that into the Revit. So prior to modeling it up into the completed 3D model lah. So but again, as I mentioned earlier, for this session, I just show how we're going to collect the data by using the point cloud. So because if we want to show that how we're gonna develop the modeling in the Revit, it will be another long session. But I believe that our fellow speaker here, Mr. Hazim, already have give the training on how to operate the Revit and BIM. And then at the moment, this is our workflow. So from the photogrammetry and from the LiDAR, so we get the data on site, and then we process the data by using, for example, for LiDAR, we process by using the cyclone registry. For the photogrammetry, we using the ArcGIS Metashape, and then after that, we export most of the ArcGIS and cyclone into the Recap Pro before we bring the Revit. Because afterward we have to build component by component based on the data that we have developed. But there are certain software that when we collect data point cloud, so by using the single button, it will be develop the modelings. So this is the software under the Leica. So at the moment we don't have that software yet. So by next year we will purchase that software for our own usage. So at the moment, this is the flow that we use in maintain the heritage building. So contrary to what we have experienced before, which is we have to go to the site by using measuring tape, laser distance meter, and then climbing over the roof, or maybe we use the charcoal to trace the ornamentation. But at the moment, no, we just bring the tools, we just bring the scanner, we just bring the drone to the site, and then we just let the tools do the works. So hopefully for every exercise we just use around 1 day to complete the data collection on the site, and then we just use another day to stitch that, to merge them together into the software. Again, software itself, you just let the software run itself to collecting, to stitching all of those image and all of the point clouds together, and then after that follows by the how we're gonna develop the model into the 3D with it lah. So this is the raw data that we transfer. So as you can see here, you can clearly see the outline, the boundary of the house that you can easily convert into the comprehensive architectural drawing in the form of the floor plan, for example. So this is from the site elevation. As you can see, the profile here, you can easily slicing them and developing the components in the Revit in a way to produce the comprehensive 3D model as our record lah, Okay, so this is the example. So after we stitch together inside the Cycla Register 360, so this is the outcome of the report. So as you can see here, the error, the accuracy is around 0.007 meter. The error is too small. So that means the data is more or less, we can call that as accurate data. So rather than we just use the measuring tape, if you use the scanner in a way to generating the point cloud, so the data much more accurate and much more the data that we can depend on lah, which is much more accurate. So this is others. So this is actually our campus at UTHM. So sad because for architecture program we just use the shop lot as our campus. This is city campus. So our main campus at Padang Raja, but this is located at the city, 5 kilometers from the main campus. So at the moment we are in the process of undergoing the facade transformation for this block. So at the moment this is our campus lah for architecture. It's a bit sad actually. Okay, so this is we are doing. This is the exercise that we ask our student to do the scanning the building. So this is the facade. So as you can see, it is point cloud. This is not image. This is the, so before they proceed into the 3D Revit. Okay, so this is another project. This is done by final year student for civil program. So which is they do the mapping survey for the roads at the Padang Raja, at the Batu Pahat, Padang Raja. So this is entirely using the photogrammetry. So they use about 1,000 pictures, if I'm not mistaken. So this is the image as you can see here. So this is the main road, and then this is the buildings that coming from that photogrammetry. So imagine that if you're gonna mapping this by using the measuring tape, so I don't know how long it's gonna take, right? But for this drone, so they fly the drone, I guess around 2 or 3 days, because this is in the middle of the road. So because they have to deal with the winds, with the rain, and then the traffic is quite heavy actually in this particular road. But they are successfully doing that by using the drone. So this you can see here, the facade of the shop lots here along the roads. So this is the profile that they are successfully taken, the data that they are successfully processed into the point cloud. So but for this, because this is, just imagine that this building itself is, the width is about 6 to 7 meters, for example. So but you can see here, numbers of the building, maybe from here to here is about 500 meter to 1 kilometer, I don't know. So just imagine that how huge the area that they covered, but they are using the tools, they are using the software, they are successfully doing that in the minimum time. Just imagine that if you're gonna map this by using the traditional method, so it will be time consuming. Okay. So this is another views. So the profile of the roof clearly visible. So this is the top part. This is the format that they use. They call that KIFF. So they're gonna use for the planner for the survey map. Okay. So that's all from me. Thank you. So I open up for any Q&A.
Okay, thank you, Dr. Azmal, for the presentation. It was very interesting. To our participant, our student, if any question, please.
Is there any question? Sorry for that technical glitch at the beginning of our session, because I don't know where's those guys coming from.
is 3D for modeling. So that's where we use Revit to start off our modeling work. And second, we have time when we include time in our model. So we go to 4D. So it's another step of dimension. And later on, once we go to another step, which is 5D, we key in cost as well. We put in cost. Another step, we go to 6D. There's where we put in performance as well. Next is 7D is for facilities management. And lastly is 8D for decommissioning. So I would like to highlight for this slide, I'll just to highlight for Navisworks itself, you can actually do, I think from 4D, 5D, 7D, and 8D. So 3D modeling, basically we will use a different software to help to model. Usually we use Revit in our practice, in our office. But again, there are a few other modeling software as well, such as ArchiCAD, what else, Tekla, and so on. And for 6D performance, there are also other software which basically you can use, such as Ecotech or even Revit itself to do some analysis or in terms of performance of your building. So there are three different types of format in Navisworks. One is NWC, second is NWF, and third is NWD. So the general interpretation of each format is NWC is the original format for Navisworks. So whenever you export your Revit model to Navisworks, it will come in NWC format. I will showcase later on how it works, what is the process. And second is NWF. This is basically the contain data from the Navisworks once you key in data from Navisworks. But this format doesn't contain the model. It only contains the data, for example, the viewpoints, clashes, and etc., but not the model. So if you were to copy this NWF format to somewhere else, you won't get the model. It will just contain the data without the model. And lastly is NWD. So in a nutshell, it's similar like PDF. So you copy the whole thing and you can just bring that file to anywhere for your presentation or for your meeting. In terms of process or workflow, this is how I basically generalized how it goes. So every consultant, for example, like architect, engineer, they open their model in Revit, they update the model, and then they export it to NWC. So once they export to NWC for each consultant or for each trade, so these NWC format will be handled by the coordinator or the BIM manager for that particular project. And that BIM coordinator manager will append all NWC files in Navisworks and become a federated model. And then once he done that, and then he will create an NWF file with all the viewpoints, issue, clashes, and data. And then that's where we go with all this circular process. Whenever there's changes needed, we will go back to the consultant or the leader to amend the project and then send back the latest NWC for the BIM coordinator to append. And once everything, for example, certain specific area have been resolved, then we can approve or publish it to the client. So this is basically a common process or workflow that we have in our office. So Navisworks, I believe from what I've been briefed by Mr. Hassan, you guys are not familiar with the software yet. This is how it looks like in interface. So it's basically the same model that you have in Revit, but it's been opened in separate software called Navisworks. To discuss about the timeline, when should we use Navisworks? So I would suppose that based on this diagram illustration, we should supposed to start actually after DD, which is design development. So that's where you have all the information from the engineer, the M&E, the structural, the civil engineer. So once you have all those model or information, then you can do coordination. So that's where we start to use Navisworks, not during schematic or not during concept. So this is my suggestion if we were to use Navisworks. So again, I've been told you guys have a bit of knowledge about BIM. So from LOD 100 to 500, so our demarcation starting from LOD 300 on, that's where you use Navisworks, because you have all the data, you have the information already placed in your model. So I think I've shown the case there's differences between LOD 100 to 500 from my previous presentation during summer course. So it just to tell you what are the differences, major differences between 100 to 300 in our case. So as I said, so during the developed design, you have all the information such as door, window, beam, sizes, columns, and so on. So that's where you going to need Navisworks to prepare your coordination tools or platform for you to go for meeting or technical meeting. Okay, this is a sample of our project, airport project that we did in Sihanoukville, Cambodia. So this is an illustration on Revit. So once you have done your model into this detail, then you can provide coordination with other trades and other discipline as well, or even with the client to showcase your design intent. Okay, to make simple differences between the Revit and Navisworks. So on your left is how Revit looks like when you open your model in Revit, and the right hand is basically Navisworks once you open it in Navisworks. So you can see in terms of the graphic wise, I mean, Revit definitely have the upper hand, but in terms of how the data is managed to be controlled or to be navigated, I think Navis would have the upper hand because Revit, the file size would be much harder to control or even to navigate. So that's why I would say once the model become more detailed and detailed, then it's easier for us to control or to manage it in Navisworks. All right, so before I continue, just let me showcase how does Navisworks look like. So even, for example, if you were to open a Revit file, so this is one sample of our project in Sri Kembangan, Selangor. It's a residential project, contains with 2 towers. So we have split the file into 3 components. One is podium, one is tower A, and one is tower B. So we have 3 Revit files. So the best way in our practice to export it to Navisworks is by exporting it individually or separate. So the process is just go to File, Export, go down. Sorry, where's my Navisworks? Okay, I don't have the tools here. So they're supposed to have a common tools here under Export to NWC. I think I didn't install that. So it's basically another tool you can export. So once you click that, it will export into several NWC files. As I said, so since this project has 3 components, Tower A, Tower B, and Podium, so we're supposed to have 3 NWC. So just to cut short, I will just show you the airport project that we did. So as I said, so for this project, airport project, we have in total, we have 16 model, including engineer, CNS, and MNE, even with the civil as well. So that shows you how complex a project can be. It depends on the scale of the project as well. So once you have all this NWC file, so you can just open Navisworks. Okay, then you can append the file. So when I say append, it's basically you load your file. So that's where you load all your NWC file. So in this case, I will just go and then load all the loading. To answer perhaps some of your queries or doubt regarding on Navisworks. So as I said, we don't do any modeling in Navisworks. This is just a tool for you to actually coordinate or to use for all sort of reason, even to do like clashes, to do remarks, review design, and what so, as I mentioned earlier in my presentation slide. So you can see now this is your combined model or federated model. So it's actually individual file. but we append all together with the same coordinate. So that's why it's been placed in the same position when we started this project. So we call it a shared coordinate. And then, so this is the airport that we did in Cambodia. So you can see once we combine all the files here, the 16 files all together, you can see everything placed into the same position or location because of the shared coordinate, as I mentioned before. So now you have a complete model. So just imagine if I only load one model, let's say architecture. So this is only architecture file that I have. Where is it? It's gone too far. So this is the only architecture file that I have for level 0. So again, as I said, it's a combination of all models that we have in a project, and then we combine it or we append it in Navisworks for us to do coordination. So that's how it works in Navisworks. So the reason why we have this, we use Navisworks because how easy it is for you to navigate. Again, just imagine if you were to open all this model in Revit, it might perhaps take you a bit of while to actually rotate even a single movement. So that's why I would say Navisworks is always the best tool for you to do coordination. Once you've done that, again, there are several usage of Navisworks. One of them is actually clash detection. So as you can see there are two ways you can do clash detection. One is through walkthrough. So I can place a human over here, third party, and then I can just walk. Okay, so you can just go through the whole building and check if there's any, for example, like clashes or what. So that is one way to do it. Another way is to do like a proper clash detection matrix, or we call it here clash detective. Okay, how we want to use clash detective is based on certain formula that we wish to issue out. So if we were to clash, detect every single component to clash, then it might take time, right? So what I would suggest is for you to come out with a matrix like what we have here. So to identify what are the main issue or the clash, the priority component that we want to check first. For example, between ducting, plumbing with RCB, for example, I would say that we consider as major clashes. So because when you model Revit, so most of the components are modeled separately because architect model in their own office or in their own file. Engineer will also model within their own office or company without architecture reflected on. So sometimes, of course, there are some issues or clashes. For example, block walls. You simply model up to the floor slab without thinking about if there's any RC beam within that. So that's why I would say that there are a few clashes which we think that it's not really valid or legit. So that's why we need this matrix to be able for us to identify what are the main clashes that we want to study first or we want to resolve first. So how to do that is basically there is a clash detective command here in Navisworks. Once you click this, so you have this tab here where you can actually add a new test, for example. And then I will just try to identify between my model. You can even be specific. For example, between a wall and RC beam. So in my case, sorry, just let me import my success first. Okay, so I have done a set here where I can categorize all the selection here already without having to do another time. So I can just select here architecture, walls. It will do the searching from the model versus structure, for example. Sorry, not what's that? Beam. All right. So I just put in some setting here in terms of the tolerance. What is the tolerance that I'm allowing for clashes, and what are the distance that is it a hard clash or is it just a clearance or what? So I can do that setting. At the moment, I will just put hard, and the tolerance is 10 mm. I'll make it bigger lah. I would say 100 mm, 0.01, and then I run the test. So now it gives me all the clashes here. So you can see, just turn off this. So now you can see from here, it will automatically detect all the clashes between wall and RC beam or framing. So in terms of the display, you can even change your display. Either you want to hide others, so you can see immediately where is the clashes happen. So again, as I said, so some of the issue with this is that if you have a construction knowledge or you have experience on site, right? So you will notice that the beam will be constructed first rather than the wall. So in reality, this won't happen at this clash, because once you have constructed the beam, and the wall will just follow according to that beam location. So the workers will never ever cut the beam just to suit your wall, right? So I mean, again, so that's where I would say that the importance of this clash matrix will help you to determine what are the major clashes that you want to resolve first, rather than those which are less priority. So talking about Navis work, so you can check all the clashes and what so, and even certain cases you can even save viewpoints. Even all this are being saved, you can even export it as a viewpoint later on. So from the report, so all these clashes, how do you want to export it as XML? You can even export it as viewpoint. So if you export as viewpoint, so it will give you all these clashes here, viewpoint. All right. So that's how easy Navis work can help you in terms of for your coordination. So that's what I said. I mean, people will, general question that I always receive is that, why should we use Navis work, not Revit? So the simpler reason is because of this. So the data is really easy to navigate, to control, and even to manage as well. So once, another tips that I would like to share, just let me close this file first. So once you have all the NWC append, and then you want to share with someone else, you can share as NWD. So you just save as, once you open that file again, sorry, I've just closed that file, and then you open it and save as NWD. So whoever have this NWD file can have all the information or data from the one that you prepared earlier. So that's how you interchange your data with others, for example, like your client or even other discipline. So yeah, again, if you have an issue, for example, like this, based on your walkthrough, and then you determine, okay, we have an issue with the lighting, for example. So we want to relocate somewhere else. So the advantage of Navis work is you can do also remarks or comment. How we do that is under the review tab here, you have this macam markup in your tools where you can use and draw on the view itself. So for example, I want to move this and tell the engineer to move it somewhere here, for example. Move this lighting as shown, for example. Okay, and the status is new. And then I press OK. Automatically, this view will be saved. So if I were to rotate and to check somewhere else, and then I want to go back to that particular view, I can just select this from my view save viewpoints, and it will just show me this markup again. And then again, if you want to see the comment, just go to under the review tab, comment, you can see this comment written where the author is me, myself. So once you have done this, and then how do I share the viewpoint to others? There are two ways. Either you want to save as this file as NWD and send it to the respective consultant, or the other way around is I can actually export this viewpoint, the whole viewpoint as XML. And then we'll just put it here. Okay, now just let me try to remove all this viewpoint. Okay, now we don't have any viewpoint. So if the person, the engineer, got this viewpoint, the XML format file, and then he opened in his NWD, so he wants to see all the comments, right? So what he can do is he can actually import the viewpoints from that XML file that we just exported. And now he can get back all the viewpoints. So just imagine if, in a BIM project, we encourage that all consultants have to update their model once a week. So every week, we will have to upload our NWC to the server or to each, so that each consultant can have the latest update from our model. So once we have the latest update model, of course, we need to see also the latest comment or changes. So if the engineer have seen this comment and he want to respond back to this comment, so he can actually add comments here. Add a comment. So says, for example, I'm the engineer, I receive this comment. So I will just say noted, updated, for example, noted and updated. And then we can just say that this is resolved. And then we say, okay. And then we, again, export back this viewpoint and send it to everyone for them to actually acknowledge that we have amended the model. So, for example, next week, we'll check the model again. If this model have not been moved or whatsoever, so we can go back to this viewpoint and see that it is not resolved. So that's how we communicate between consultants in a BIM project. So that is one advantage of why we use Navisworks in our office, because how easy it is to manage data or even communication within the stakeholders. So another advantage about Navisworks is the ability to create section, again, also to navigate. So you can create any sections, any in terms of vertical or horizontal section for you to check individual or specific spaces that you wish to review. For example, if I just go down to this plane, I can check in terms of plan. Same go with, for example, if you want to do a vertical section, right? So I just change the alignment to a surface, for example, this wall, and then I can have a section of my building immediately. And how it is easy to control and to manage this file, it seems really amazing, I would say. If I were to do this in Revit, definitely it will take me minutes to even rotate my view or my angle when I have all the models linked. But in Navisworks, you can just cut down short the whole process or the whole timeline to navigate the model. So if you say that this is, okay lah, boleh lah, this is really a small project. So I will just want to show you a different project that I did in Abu Dhabi, which is the theme park project, Warner Brothers theme park. So the file itself here, it mentioned is 3.6 gig, but this is an NWD file. Just imagine if you were to open the Revit file, it can go even till 100 GB altogether if you want to combine all discipline, all trades. But now you only have 3.6 gig file. So that's how Navisworks can actually, not to say simplify, but to minimize the file size, because they don't have any authoring tools, they cannot amend any model, they can just do coordination and just to navigate to manage. So yeah, that is one of the major reasons why we use Navisworks in our practice, because how easy it can do, especially in terms of management, data management. So just give a few seconds for it to open. Okay, to give you a brief about this project, in general, for your imagination, this is a 100-acre indoor theme park. So just imagine how big it is. I can give you a skill later on with walkthrough. In summary, it's basically like a 4 city within a building in a big factory, huge factory. So that's how big this project is. Open. Sorry again, everyone, because I think this is plan B for most of us, the presenter, because we've just been told that today is a public holiday announced by our new Prime Minister. So I was planning to have this presentation in my office, but unfortunately because of public holiday, it's closed. So I have to do it on my laptop and in my house actually. So yeah, I mean, if I were to use my own desktop, it would be much faster and perform better, but I just have to use whatever I have right now or use my laptop. Give a bit of second to open that file. Okay, so this is the theme park, which is located in Yas Island, Abu Dhabi. So as I said, in total it's 100 acres lah, including the site, the overall site, including parking and what. So, but the building itself, I think is approximately around 40 to 50 acres in terms of size. Everything is indoor because UAE is a bit hot, so they plan to run this theme park all over the year, including during summer. UAE have the weather is not so good, especially during summer. It can be hot even till 50 degrees Celsius. So that's why they do this project indoor so that it can operate even during summer. So yeah, actually, this is a project back in 2018. So I'm giving a virtual walkthrough in this project. So I save you in terms of the cost of the ticket itself. Just joking. So you just go through, and this is the main entrance lobby where the ticketing is. So this is the gate, e-gate, and what so. And then you go to one city to another city. So you have all the shops on your left, and this is the city. So basically, it's a building within a building. So you have not just a building, a city within a building. So all this ceiling on top, right? These are all been painted with certain graphic and what so. So all this building each have function. For example, like shops or even rides or theme park. So this is what we call it as Warner Brothers Tun Junction, the main plaza. So this is where all the main activities will be held. And then if I go to this side, so you walk through a tunnel and then there are shops on your left and right. So this is Justice League, or we call it, sorry, it's been a while, I can't really remember all the name. Metropolis, if I'm mistaken, a city of Metropolis. So this is, if you're familiar with DC punya character, so this is Superman, the Daily Planet building. So you can see this is the building. It looks similar to the one in the movie. And then if you go inside, there's the rides and what so. So if you go on the left, you have the restaurant, Big Belly Burger. What else? This is Man, The Flash, Cyborg, Wonder Woman. I think this is Green Lantern. The other one is Aquaman. So with Navisworks, you can do measurements. So this is the exact scale of the project. So there's a tool for you to measure. For example, if you want to check what is the height of this statue, so you can do that measurement. It's 4.26 meter. So this is another reason I would say why we use Navisworks. in our project because you can do multiple stuff, especially markups. So when you're dealing with, sorry, this is not supposed to be 4.2. I think I tagged it wrongly. So I think it's supposed to, it is 4.1. So yeah, you can do markups, you can exchange information with different people or different stakeholders. So that's why I would say Naviso is still a tool to be used for people or even for students, for them to study or to use for their project. So going on, I just have to walk. So every building have their own, not just every building, some buildings have their own, for example, like rights and what so. So for example, Justice League, this is our right. So this is how the right looks like. So once you queue and then you pop out to your right and then you just go through this basically there's a circulation around it. So if I want to show you in plan, so that's how it is from this point here, the entrance, you go all to the queue. I mean, some of you guys might have been to theme park before, right? So you need to queue first before you can even enter the ride. So this is how this theme park operate as well. So you have queue point, and then we have the rides, which is basically here. So this is the circulation moving towards here, circulate, and then you exit back to the same place, and then you exit to the hall. So I mean, in general, this is how big this theme park looks like from bird eye. So you got Metropolis on one side, and then this is Gotham, which is Batman. So this red thing is Batman punya right. And then the Afiu. This is the Toon Junction, Cartoon Junction, where you have Tom and Jerry, you have Annie Mayhem. So yeah, I really hope that you can imagine the scale of this project, how big it is. So by using Navi's work, it's possible for us to see everything combined in one file. So if we were to do this in Revit, I don't think we can even manage to combine it 2 files only. So that's why I said Navis will give you the advantage to make the file much more easier to navigate or to manage. So some of the technology that we use, for example, some in this Anime Mayhem punya ride or punya attraction, we have this rock work. We call it rock work. It's a handmade, man-made punya artist impression on the rock work itself. So what we did is first we model it, and then after it's completed or been constructed on site, we will scan it. And once we scan it, we will import this data or this mesh as what the earlier presenter, Dr. Azmal, have presented. We can import back this information data to Revit so that we can actually use it for SBuild and for whatever reason, or even for facilities management later on. So that's how we use also 3D scanning to help us to model or even to scan certain thing which is really hard to model, and we just use the scan version and the 3D scanner for us to import it as a data or geometry in our model. So as mentioned by Dr. Azmal previously, we use Recap, we use 3D scanner Faro. In this case, we have multiple station been positioned because how the 3D scanner works is basically it will just point out all the points. So there are millions of points. If you can look from this Recap software, right? There are millions of points once a station have been placed in a certain location. So once that points have been taken, and then just imagine we have several stations, and then we can use Recap Pro to actually merge or to stitch those points which are overlapped. So if you see this, the file that we have, you can see the rest of the area are not been scanned because, as I said, the station or the scanner is being placed somewhere. For example, like this point here, the circle dome. So once we put in several position of the scanner, then it can actually stitch, or it can just basically shoot out all the point clouds to within a certain radius. For example, it depends on the equipment itself. So once you have multiple point of selection, then you can have so-called files. We call it an RCS format file or data cloud file. So either this file you can actually open in Navis, or you can even open in Revit. So if I were to open this in Naviso, also I can actually open this RCS file in Naviso as well. So how I do that? Sorry. Give me a few seconds. It's in my hard disk. Okay, this is an NWF file. So it contains the data that I've mentioned earlier. So NWF doesn't contain any model. It just contains the data, either your imported RCS or what so. So if I were to check the so these are all RCS. RCS is the scan file, the point cloud file. So if I rotate this in Navisworks, so I'm opening in Navisworks, as mentioned earlier. So you can see it's loading. It contains millions of point cloud. So it's basically like a photo that you stitch all together. So it's not basically a real photo like your 2D camera or whatsoever. But again, it contains millions of point cloud, which it's close to each other and give you that impression it's basically a photo. But it's not. It's basically a 3D point cloud. And then once you have this, and then as I said, you don't have the model here. These are all only point cloud. So what you do is you go back to your home tab and then append the model. So find the exact model that belongs to this particular scan. For example, I think this is a C1B CB. So I just load back the model, the NWD file, which is basically derived from Revit, from the authoring tools, either you're using Revit or ArchiCAD, or even other software Tekla as well. So once you load this file, then you can have a verification between your model and the one which was being built on site. So I think to answer a question that I believe some of the students have asked before, so how about a project where basically this is still in progress and what so? So this is how we use 3D scanning in our project. So it's still under construction, and then we can have multiple timeline, as mentioned from Dr. Azmal. So because perhaps when we constructed a building, right, there are few layers of few schedule. So first you have to model, start off with the structure, the main structure, and then you have to scan. Okay, once you've done that task, and then it goes to, for example, all the services, mechanical, plumbing, electrical, and so. So once done that, and then we scan. So the third layer, for example, all the architecture finish. That's where you put in your walls and what so, and then you do another scanning. So that's how basically, it's not basically a one-time scanning. So if you're doing a completed project, for example, like a heritage project, perhaps you can do that. But if it's a construction project, under construction project, a new project, then you have to have several times in scanning for you to verify if every component has been built as per what we've modeled in Revit. So that is one of the usage as well, how we share this viewpoint or this screenshot to the client and tell them, look, there is some deviation between the design and then the one that we constructed. If they can accept this differentiation, then they will sign off and then say, that, okay, they accept. So that's how we do site verification for a new project, and specifically for this particular project in Warner Brothers theme park. So yeah, that is, I don't know, I have perhaps given you several usage of Navisworks. And the other two, which I suppose, which is timelining and quantification, we hardly use in our office at the moment. Quantification is for you to do quantification, the 5D quantity takeoff. For example, if you want to export numbers of doors, the wall area that we have, the numbers of RC beam, so you can actually do that in Navisworks. Same go with Timeliner. Timeliner is more for your 4D scheduling. So if any project that you do, you have a work program, right? As I mentioned earlier. So perhaps for first 6 months, it's basically only structure or the foundation, the column, piling, and so. And then you will get that information and plug into Navisworks and link to your model. And it will give you a simulation on how it basically constructed. So that is actually Timeliner. If you want me to demonstrate just a quick one, I'll try to give you an idea how it looks like. Okay, if I go to Timeliner, right? So I've done this. So I've keyed in, for example, structural wall based on certain dates. So what is my plan start date, plan end date, actual start, actual end. Okay, and I link to the model itself. So once I've done this, just as a disclaimer, we hardly use this tool. But again, if you are a contractor, I believe this is a really important tool. So you can actually simulate. So I just play the knee, and then it gives you some sort of like with a timeline, and it gives you that so-called simulation. So if you have a really detailed task or detailed planner, then it will become much more livelier. For me, for now, I'll just give you two basically simple tasks. One is the wall, and the other one is the RC beam. So that's why the simulation is only like really simple. But if I go back to the task right here, so you can also link this one to any programmer planning punya software, such as like Primavera, Microsoft Project, and what so. Then you can actually import that data. So here you can actually import the data, or you can do it manually. So if the tasks have been detailed up to a certain extent, for example, based on each level or each floor, then you can have a better simulation for the whole building. At the moment, I'm just giving you a simple demonstration. You can do that in Navisworks as well. So that is 4D. And now if we want to go to 5D, which is quantification. So what Revit gives you, so did I manage to, okay, for example, like this, right? So I can export all these data. So for now, calculating how many doors that I have in this project. And I believe I also checked what are the beam that I have. Yeah. So beam and door. So once I've done this basically process, I can export this to Excel. So with this data, you can give it to your QS and also for them to put the price or the rates for each and individual component. So that is how, again, how quantification can be used in Navisworks. So you got 4D and now 5D. So again, it gives you is the size of this beam, for example, and the length and the height. So you can see here the model length, the model height, and what so. And same go if you go down, scroll down a bit. Beam, RC beam. Now you got the door. So you can calculate how many doors do you have, for example, FD1. So give all this information to QS. QS can actually key in the rates and whatsoever from the supplier, from the manufacturer. So that is 5D in Navisworks. So I believe, what else do we have here? Sorry, my laptop will just crash, but I believe that's all for Navisworks. If there is any question, just let me know. Hello?
No, yes.
Yes, got it. So my laptop just went off just now, shut down. I'm trying to restart it. But is there any question so far?
No question so far, but it's okay. We can wait.
But again, I believe I think I'm almost done with the presentation for Navisworks. Yeah, just let me know if there's any question from the audience.
Sure.
Okay. Sorry for the technical lag just now. So again, just to continue my presentation slide, I would say this is Matrix, and then this is the software that we use. So yeah, you can open multiple files in one Navisworks window. For airport project, for instance, we have approximately around more than 10, I suppose, for the whole building. And this is the Warner Brothers theme park project that I just shown earlier. Different trays with different color, 3D scanning, and then you use that 3D scanning to basically use it as a geometry or a mesh to be inserted in Revit for as-built. So yeah, I think that's all from me on the research. Is there any question from the floor?
Committee, please unmute. Hazim. Hello, committee. Committee, hello. Can you unmute Hazim?
Hello?
Okay then, Miss.
So far?
Yeah,
From the floor, from the student?
no question so far.
I think I'm ending my presentation already, so I don't have much. So just let me know if there's any question from the student or from you guys, lecturers.
Hazim, someone raised Rindu Shabila. Rindu Shabila?
Yes, please. Rindu Shabila.
Okay, thank you, Mrs. Rati. Let me introduce myself. My name is Rina Syabila Alisa from Civil Engineering and Architecture 2020. I want to ask, the modeling described earlier represents site or landscape analysis modeling. It is pure modeling from scratch or using tools from data collection. Then, if you use a tool, what tools do you usually use to connect to this Navisworks software?
Sorry, can you repeat that question again? Rindu Shabila? The line was not really clear, the audio.
Okay, Mr. Let me repeat the question.
Mhm.
The modeling described earlier represents site or landscape analysis modeling. It is pure modeling from scratch or using tools from data collection. Then-
Oh, okay. The second question is?
Okay, then if you use a tool, what tools do you usually use to connect to this Navisworks software?